moving parts of the body. What is going to be the response to the stimuli? Everything we do, in some way, makes a memory. Now, not everything has to become long-term. There's quite a bit of work required by the brain, the neurons, chemicals, all these different pieces coming together for it to make an actual long-term memory. And then for memory, we've got other things that maybe we have to know the procedure to do it, but we don't necessarily have to think a whole lot about it. For example, walking. Other than waiting for that 9:15 time frame, when I'm going to say, okay, take a break, be back at 9:30, do you really think about walking? Do you have to physically tell yourself to put the one foot in front of the other? Why? How old did you say your child was?
1, like 10 days.
And trying to...
Oh, she's walking.
Now, in the process of learning that, what kind of things have happened?
I mean, you kind of have to coax her a little bit to do it. She still tries to crawl most of the time, but sometimes I think it seems like it pops into her brain. Like, oh yeah, she'll walk. She'll walk up, yeah.
And is there a lot of unbalance?
Yeah, I call it jumping.
I like that touch.
She like gets going to like one side, kind of like, you know, after you've been like spun in a circle for a while. Just off balance.
And then probably a lot of falls.
Yeah.
Because I think we mentioned, I think that's one of the reasons that they make diapers thick. Because what is actually happening, the body is learning a procedure. It's a training process that is taking place. So that as it continues and you get better and better and better, you're no longer having to think about doing it. In some jobs, this is what happens. If the person has a certain movement or something that they do constantly over and over and over, they finally get to a point where they're no longer thinking about it. They just do it. Okay? So we do have memory that is considered procedural. All right? We have other types of memory that are going to come into play, and then memory actually becoming long-term is something totally different. Memory is a cognitive function, meaning we are getting and using information. We've got to acquire the information. Maybe that's reading, all right? Maybe it's reading something from your text or your lab manual. Well, if I did that, in order for me to store and retrieve it, I have to make it in some way memory. Now, that's going to become something totally different. And in some cases, information that we get or information that we come across doesn't necessarily have to be anything that we actually have to keep. Some information we can actually forget. Ever hear people go, look, I've forgotten more than you know? Ever heard people say stuff like that? You know, when people get really old, they'll say, I've forgotten more than you ever know. You know, I'll be like, really? What the heck? So, areas of the brain are going to have to help with this. The hippocampus. I'm sorry, I have to write. Because I think about how Kansas name like hippo. That's just me, okay? Now, it's part of that limbic system. Do you guys remember that? How we had in like the brainstem area, and then we had some branching out that looked like it went into rays for sun, going into other areas of the brain. You guys remember this? Okay. It is a very important memory forming area. Why? Now, in addition to that, all right, think back to the location of it. We're at a location of where it's close. This limbic system is close to our brain stem. What is the brain stem responsible for?
Basic function.
Instinct.
Homeostasis.
Basic. Homeostasis. Right? That's picking up on a lot of other information. It's picking up on the temperature around you. It's picking up on the amount of light. It's picking up on smell. It's picking up on sight. You see where I'm going with this? Memories are usually formed when something else is associated with it. So, in this area, we do not store any memories. It does help us to organize sensory information. The sight, the smell, the sound, the taste, the feel, the sensory information that came along with your new information you got. Have you ever heard that when you're reading, you should be listening, or when you're reading or studying, you should be listening to Beethoven or Mozart, classical music? Why?
Associated with the sun.
It actually gets another area of your brain to work, and the area is your spatial ability. Spatial abilities are very important. Have you ever done an IQ test? An actual IQ test? Okay. One of the parts of it is spatial reasoning. I guess because I heard that fact so long ago about listening to classical music while you study, I scored very high on spatial reasoning. It's that ability to look at different pieces and put them together without actually touching anything. Yes. You have to figure out how do they fit together without actually moving them. You can't move them around. But what that does for you is it allows that information on this area to actually form. So it takes in all that sensory information. The sensory information was something sound. But for the most part nowadays, how do we tend to read and study? We're plugged in, probably. Got music blaring. Stuff might be playing on the TV, might be having the radio on, might have both. Okay? That is not allowing your brain to form any memory of what you're doing. So it becomes very important how information goes in, what's coming along with it, because if you're trying to do something, the long-term memory, if conditions are not exactly right, it's not going to form. If you do not get your sleep, 8 hours, good sleep, not where it's just all, moving and tossing and waking up and everything like that, the long-term memory will not form. The way that we form long-term memories, your brain has time to create the file and put it on the desktop. And that is done while you sleep. Because that's when chemicals can get released to form. Memory, well, we have to teach our cerebral cortex. What part of the brain is that? Cerebrum. Is that asking about cerebral? And then the cortex. What region was that? The outer portion of the gray matter. You got to teach it. Long-term memory comes through a lot of different areas. For example, vocabulary. How do we learn vocabulary? Repetition from when? Yep. As soon as that baby developing can hear something.
In the womb.
In the womb. Read to it. Play music. Everything. When it gets here, read to it. Play music. Stimulate them. Alright?
So just something interesting I found is like when I have my baby and we ask her a lot of questions like how are you doing? We have that questioning inflection in our terms a lot with her. I noticed that she started making her sounds with that like questioning inflection on her, so like that, and so I kind of thought about that. I'm like, why is she doing that? Probably because we ask her a lot of questions because she can't respond to a lot of this. She can't have conversations. So I kind of stopped doing that.
Why?
Well, not completely stopped, but I started to talk to her and actually like have a conversation with her, like walk around the room and like point things out to her, and and instead of the questions we develop like, wow, maybe she's not learning other questions as much as she should. Just trying to like spread it out.
Right, I understand, because you're wanting to make sure that she understands when you put that inflection into what she's saying. Very, very important. And the way that you talk to them, okay? What you show them, what you teach them, everything, okay? Right now, for example, vocabulary is going to be repetition. And then eventually, they'll start figuring it out, okay? And for younger children, the one thing you want to do is stimulate their brain cells as much as possible. You want to have pretty colors. You want to have a lot of light. You want to have lots of different sounds that they can hear. Facial memory. Was yours or who was the first face?
I guess probably the doctor.
The doctor? Yeah. same type of